My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Unix programming as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: discuss about asynchronous I/O. Asynchronous I/O, AIO, means doing input-output operations without blocking the program. In normal, blocking I/O, when a process reads or writes data, it must wait until the operation finishes. But in asynchronous I/O, the process continues its work while the I/O happens in the background. This is very useful in network programming because reading from sockets can take time. With AIO, the program stays responsive and handles multiple tasks smoothly. Example, easy to understand. Suppose you order food online. After ordering, you don't sit and stare at the app until food arrives. You continue your work, and when the delivery person comes, you get a notification. This is similar to AIO. The program starts an I/O request and continues working. When the I/O finishes, it gets a signal or callback. In Unix, Unix provides asynchronous I/O with system calls like AIO_read, AIO_write. Notification using signals like SIGEV_signal. In short, asynchronous I/O helps programs work faster, handle many connections, and avoid waiting unnecessarily. Next important short question is: 2. Define out-of-band data in socket communication. Out-of-band, OB, data in socket communication is a special type of data used to send urgent messages over a TCP connection. Normally, all data travels in order, like people standing in a queue. But OB data allows a small amount of information to jump the queue and reach first. TCP supports this through the urgent pointer, which marks the data as urgent so the receiving side can process it immediately. Easy example. Imagine you are talking to a friend on a phone call, normal data. Suddenly you need to say, wait. Important. That urgent message must be heard immediately, even before the normal talk. This important message is like out-of-band data. In Unix, OB data is sent using the flag send, sock, MSG, lay, MSG_OB. It is received using receive, sock, buff, lay, MSG_OB. In short, OB data allows sending urgent information quickly without waiting for regular data to be processed. Next, Unit 3. Long questions. First important long question is: socket programming, socket address. Socket programming in Unix is a technique that allows two computers to communicate with each other over a network. A socket acts like a connection point similar to a telephone connection between two people. One program sends data, and the other receives it, just like talking over a phone line. A socket is created in Unix using the system call socket, domain, type, protocol. Domain communication domain, example, IPv4. Type of connection, example, TCP or UDP. Protocol usually set to 0, system chooses automatically. After creating a socket, we generally perform steps like bind, listen, accept, connect, send, and receive. These steps help two applications talk to each other across networks like LAN, Wi-Fi, or even the Internet. Socket address. A socket address defines where the data should go. It contains two main things. 1. IP address identifies the machine, like a home address. 2. Port number identifies the application inside the machine, like a door number. Unix uses structures to store socket addresses. For IPv4, we use struct sockadder_in, short sin_family, address family, af_init, unsigned short sin_port, port number, struct in_address sin_address, IP address. The port number helps the operating system deliver data to the correct program. For example, port 80 web server, port 22 SSH, port 25 mail server. Easy to understand example. Imagine sending a parcel. You must write house number, port number, street area, IP address, city type, address family, example, IPv4. Only when all details are correct will the parcel reach the right person. Similarly, for a socket connection, the computer needs a proper socket address so data is delivered to the correct application on the correct machine. In simple words, socket programming is the method of making two computers talk to each other, and the socket address is the postal address that guides the data to the right destination. This makes network communication easy, powerful, and flexible in Unix. Next important long question is: 2. Describe elementary socket system calls. Elementary socket system calls are the basic building blocks used in Unix network programming. These calls help create a socket, give it an address, listen for clients, accept connections, and exchange data. They form the foundation of every client-server program. Let's learn them step by step in simple words. 1. Socket. Create a socket. This call creates a communication endpoint. int sockd is equal to socket, af_init, sock_stream 0. af_init IPv4. sock_stream TCP. sockd socket file descriptor. Example. Like purchasing a new mobile phone. You need the phone before you can call anyone. 2. Bind. Give address to the socket. Bind assigns an IP address plus port number to the socket. Bind, sockd, struct sockadder asterisk, and other, size of, other. Example. It's like getting a SIM card with a phone number. Now people can reach you. 3. Listen. Wait for clients. Server uses this to start waiting for incoming connections. Listen, sockd, 5. Example. Like switching your mobile to ready to receive calls. You are now open for incoming calls. 4. Accept. Accept a client. When a client requests a connection, the server accepts it. int need is equal to accept, sockd, null, null. Need is a new socket used only for that client. Example. Your phone rings and you pick up the call. Now you can talk directly. 5. Connect. Client connects to server. Clients use this call to reach the server. Connect, sockd, struct sockadder asterisk, and server, size of, server. Example. Dialing a phone number to talk to someone. 6. Read and write, receive, and send, data transfer. These calls help exchange data once the connection is established. Example. Talking with your friend after the call is connected. In simple words, elementary socket system calls are like the steps of making a phone call. Get a phone, get a number, wait for calls, answer, talk. They are essential for building any network program in Unix. Next important long question is: 3. Describe advanced socket system calls. Advanced socket system calls are special Unix functions that provide extra control, better performance, and more flexibility than basic socket calls. They help manage multiple clients, control data behavior, handle urgency, and deal with special network conditions. Let's understand them in an easy and interesting way. 1. Select, monitor many sockets. Select lets a program check multiple sockets at the same time to see which one is ready for reading, writing, or errors. Select MXFD plus 1 and refs null, null, null. Easy example. Imagine a teacher watching many students. She answers whoever raises their hand first. Similarly, select watches many sockets and picks the one that becomes active. 2. Poll, similar to select but more efficient. Poll does the same job but works better when there are many connections. Example. A security guard checks many doors. Poll is like a modern guard with a device that tells instantly which door needs attention. 3. Request and sends, advanced data handling. These calls allow sending and receiving multiple buffers. Control information. File descriptors in Unix domain sockets. Request, SOCFD, and MSG 0. Example. Instead of sending one small parcel, you send a big package with multiple items and instructions inside. 4. Get socket and set socket, get set socket options. These help control how a socket behaves. Set timeout. Set buffer size. Enable disable broadcasting. Set socket, SOCFD, sol_socket, so_reuceder, and val, size of val. Example. Just like changing your mobile settings, brightness, ringtone, or data saver. 5. IOCTL, control socket at low level. IOCTL performs special control operations like making socket non-blocking, checking number of bytes available, retrieving device details. Example. It's like opening the phone's engineering mode to access extra features. In simple words, advanced socket system calls help programs manage many clients, control socket behavior, and handle complex data, making Unix network programming powerful, scalable, and efficient. Next important long question is 4. What are reserved ports? What are reserved ports? In Unix networking, reserved ports are special port numbers from 0 to 1023. These ports are also called well-known ports. Only root, administrator, can use these ports because they are linked with important network services. This restriction prevents normal users or hackers from misusing them. These ports are like VIP parking slots reserved only for government vehicles. Common people cannot park there. Similarly, only trusted system services are allowed to use reserved ports. Why are they reserved? Reserved ports ensure 1. Security, only root-run services can use them. 2. Standardization, everyone knows which service runs on which port. 3. Reliability, applications can easily find the correct service. Without reserved ports, services could run anywhere and communication would become confusing. Examples of reserved ports. Port number service purpose. 20. 21 FTP file transfer. 22 SSH secure remote login. 23 Telnet remote terminal. 25 SMTP email sending. 53 DNS domain name resolution. 80 HTTP web server. 443 HTTPS secure web server. When you type http:// your browser automatically connects to port 80. When you type HTTPS, it connects to port 443. These ports must work the same on every computer worldwide, which is why they are reserved. Easy to understand example. Imagine a railway station. Some platforms are reserved only for VIP trains like Rajdhani or Shatabdi. Normal trains cannot use those platforms. Similarly, reserved ports 0 to 1023 for important system services. Non-reserved ports 1024 to 65535 normal apps like WhatsApp, games, etc. If anyone could use port 80 or 22, someone could create a fake server and trick users. That's why Unix allows only root-owned applications to open these sensitive ports. In simple words, reserved ports are 0 to 1023, kept only for important and trusted network services. They help maintain security, standard rules, and smooth internet communication across all systems. Next important long question is 5. Explain about input-output multiplexing. Explain about input-output multiplexing. Input-output I/O multiplexing is a technique used in Unix that allows a single program to monitor multiple input-output sources at the same time. Instead of waiting for one socket or file to become ready, the program can check many sockets together and react immediately to whichever becomes active first. This is extremely useful in network servers, where a server must handle hundreds of clients at the same time without getting blocked. Unix mainly provides two system calls for I/O multiplexing: select, poll. Both perform a similar job: watch many file descriptors, sockets, and report which ones are ready for reading or writing. Why is I/O multiplexing needed? In normal, blocking I/O, a program waits for one socket to receive data. If nothing comes, the program becomes stuck. But in real-world server applications, web servers, chat servers, multiple clients may send data at different times. I/O multiplexing solves this by allowing the program to handle many clients with a single thread or single process. How select works? Simple explanation. Select checks three possibilities. 1. Read-ready sockets. 2. Write-ready sockets. 3. Sockets with errors. The moment one of them becomes ready, select returns. Easy example. Imagine you are the only person managing 3 shop counters. Instead of standing at one counter and waiting for customers, you watch all 3 counters at once. Whenever a customer arrives at any counter, you go and handle that counter immediately. This is exactly what I/O multiplexing does. It watches multiple sockets and responds only when needed. Benefits: efficient handling of many clients. No wastage of CPU time. Works well for chat servers, game servers, web servers. Reduces need for multithreading. In simple words, I/O multiplexing allows one program to listen to many sockets at the same time using calls like select and poll. It makes Unix network servers fast, efficient, and capable of serving many clients easily, just like one person watching multiple counters and helping whoever comes first. Next important long question is 6. Discuss about Internet Super Server. Discuss about Internet Super Server. The Internet Super Server, also called Ineted or its modern version Zinet, is a special program in Unix that manages many small network services. Instead of running separate servers for FTP, Telnet, Finger, Echo, etc., Unix uses one single super server to control all of them. Think of it like a multipurpose switchboard operator who listens to many phone lines and connects calls only when needed. How it works? Normally, every service, like FTP or Telnet, would need to start its own server and keep running all the time. This wastes memory and CPU. The Internet Super Server solves this problem. 1. It listens on many ports, like 21 for FTP, 23 for Telnet, etc. 2. When a client connects, it starts the required service program. 3. After starting the service, it hands over the client connection. 4. When the service finishes, the program ends, saving resources. Why is it called super server? Because one server controls many other servers. It saves system resources and simplifies management. Easy example. Imagine a big apartment building with one security guard at the entrance. Instead of having separate guards at every flat, this one guard watches the entire building. If a visitor comes for flat 101, the guard informs the resident. If another visitor comes for flat 202, he calls that person. Similarly, the Internet Super Server watches multiple network services and wakes them only when needed. Common services managed by Zinet: Telnet, FTP, Echo Service, Time Service, Chargen, Talk Service. Benefits: saves CPU and memory. Easy to manage many small network services. Starts services only when required. Provides logging, access control, and security features. In simple words, the Internet Super Server is a central controller for many small network services. It listens on several ports, starts the required service when a client connects, and stops it after use. This makes Unix systems efficient, fast, and easy to manage, just like one smart security guard handling many apartments.